Hello and welcome to my channel. In this tutorial we are going to discuss the factory method and the abstract factory design patterns. And we are going to implement those design patterns in TypeScript. I have prepared here a UML diagram which represents the architecture of the program that we are going to build. We are going to discuss each part of the architecture individually. So don't panic if it looks complex. It's not. So let's get started. So we are going to talk about the factory method first, and then we will continue to discuss mixing the abstract factory with the factory method, and then finally we will be talking about implementing the abstract factory itself. So suppose you have an interface which represents the suppose you have a game, and in that game you have artifacts, and those artifacts can be, for example, a bomb, an NPC, non-playable character, or an enemy, or other stuff like the player, some obstacles, houses, etc. But we're going to stay simple. So we will be having only three artifact types, and we will be implementing a class structure that represents those types. So we are going to implement a base game artifact class that will represent an artifact in the game. And that class will be having a name property for each artifact, and some method like act, for example, like do something, and move, like move from place to place. And from this class, we will be subclassing other three classes. For example, the enemy subclass will be representing enemies in the game. A bomb will be, or weapon will be representing bombs or weapons in the game, and non-playable characters will be representing non-playable characters in the game. Each of those subclasses will also be inheriting the methods that we have defined in the base game artifact class. And of course that base game artifact class will be implementing the interface. So we are talking TypeScript here. So let's get started. I will be discussing the other classes and other parts of the architecture later. So at this moment, just remember this. We have one artifact type enumeration that will be representing a bomb, an NPC, an enemy type. And we will be having an interface that represents game artifacts, and we will be having a base class called base game artifact that will be implementing the interface, and we will be having three subclasses that will be extending the base game artifact. Those are enemy, bomb, and NPC classes. So let's get started. I have a empty directory here, and I called it the factory design pattern in TypeScript, and I only have the VS Code directory created with settings for Dino, because I'm going to use Dino for implementing this program. And of course the settings for Dino can be found in the Dino official plugin. If you go to the extensions and you type Dino, if you install the DinoLand extension for Dino, then you can copy the settings from that plugin, and I highly recommend that you do so. If you are using another method to program in TypeScript, like for example the main compiler for TypeScript, then please continue without doing this. Personally, I'm going to use Dino for that. So we need to first declare our interfaces, and I'm going to create a file called interfaces ts, and I'm going to export an enumeration called artifact type, and I'm going to define a bomb which will be taken the constant 1, npc enemy, and then I'm going to declare another interface which is called interface game artifact. Okay, and that interface will contain three properties. One is the name of the artifact, which is of type string. We will be having a move method, which will be returning void. Depends on your application, of course, that these methods can return whatever you want, so it depends on your implementation, but for me we are returning void. So after that we are going to declare a main file ts, and I'm going to declare also another file called game elements, and here we are going to declare all our classes for the elements. So the game element will be importing the interface, of course, because we need that. Game artifact from the interfaces. TypeScript. Okay, and we are going to implement the base class, which is base game artifact, which implements the iGame interface. Okay, and we are going to declare a constructor that is going to take a name property, and of course if you say public before in front of the parameter that you are receiving, then TypeScript will create a field, data field, with this name, and it will be publicly accessible. So if you don't want to declare it, like if you don't want to do something like that, name string, if you don't want to say then this, this name equals name. So if you don't want to do that, this is a shortcut. Okay, so in that constructor we are just going to output what we have done here so far. So I'm going to say this name was created. Okay. Next I'm going to define the move operation, cons log base game artifact move. Okay, just to let us know that it's executing this operation during runtime. Yeah, I will finish writing this. So let me copy. So all right, so yeah, this is the base class. The philosophy of the factory method is this. During runtime, you might not know what type of class, what type of artifact you want to create. I mean, during compile time, when you are like at this moment when we are planning to program our software, we don't know how many enemies we are going to create, when we are going to create them, how many bombs, NPCs, etc. And we are going to let the factory method decide. Actually, it is said that the subclass is the one who's deciding when to create what, but it's not actually like that. It's basically the system deciding at a certain moment that it is appropriate at this moment to create, for example, an enemy instead of a bomb or instead of an NPC. So we will be calling this factory method, and that factory method will be receiving a parameter that will be deciding what type of artifact we are going to return. Okay, so back to that. We are going to create a class bomb, which will be extending the base game artifact, and constructor, of course, public name string, and we will be calling the super here, and we will be logging out what's happening here. So I'm going to say that it's bomb, and it's logging out the name property created. Okay, we are going to do exactly the same, so I'm going to copy this here. So it's going to be bomb, yeah, bomb move. Actually, I'm going to say something more funny. Bombs don't move. Okay, and when acting, I'm going to say boom. You get the idea. Right, so now I'm going to copy this, and this will be the NPC, and NPC well, for example, let's say alright, this name, let's say, is walking slowly. NPCs usually walk slowly, so okay, stay a while and listen. If you know who's that quote from, it's actually Descartes Kane from the Diablo game, if you know that, which is a very famous game. So now we can go and declare the enemy class. Okay, and the enemy class will be actually something like okay, right. Okay, so now we have created the base game architecture, the base game elements, and we are going to create another file now called the factory, and that factory file will be implementing the factory method. So we are going to import from interfaces, and we are going to import the artifact type at the moment. And from the game elements, we are going to import NPC, enemy, bomb from game elements TS. Okay. I'm going to create a class and export it called factory. Class factory. And I'm going to create a method called create game artifact, and that game artifact will be that method will be receiving a name property of type string and element type of type artifact type. Okay. And what it's going to do is going to check what is the value of the element type, and based on that it will return the appropriate game element. So we are going to make a switch statement. We are going to check the value of the element type, and here we are going to see how many cases we have. We have artifact type bomb, for example, and in that case I'm going to return a new bomb name. Okay. The same goes for the NPC. So artifact type NPC, and in that case we return a new NPC with a name. And last thing is when the artifact is an enemy, return new enemy with name. We can also make a default case for error checking if in case something, the wrong element type was entered. We can do something like that, throw unsupported game artifact type. Okay, so we can do this. And I think that's it for the factory method. We can try it now. So let's import the factory from okay, let's do something like that. We will instantiate our factory, so we will say factory equals new factory, and after that we will be starting creating our elements. We will have also to import the interfaces, the enemy type, which is from the interfaces file, and that will be artifact type. So const let's say Descartes Kane, which is our NPC, equals factory create game element, and the name is Descartes Kane, and the type is artifact type npc. Okay, and we will create a bomb. We will be saying factory create game artifact nuclear, and it will be artifact type bomb, and also we will be creating an enemy. And who's that? Probably Diablo itself. So factory create game element Diablo and artifact type enemy. Right, now what we can do with this is Descartes can act. Actually, first he moves. So move Descartes can also act. He will be saying something. The bomb can move or not. Well, it can fall on someone. Bomb act. Okay, and Diablo can move. Diablo also can act. Okay, console log the end. Okay, let's try this. So I'm going to open a terminal and I'm going to say Dino run allow read main ts. Okay, so we can see now first Descartes was created, NPC was created. That's the base class. It's telling us that the base class was created. Then nuclear bomb was created, and the base class is also confirmed that. The enemy was created, etc. And then we are executing the actions and movements. So Descartes is walking slowly. Descartes is saying stay a while and listen, and the bomb explodes. Diablo is charging forward. Diablo has attacked you. You lost 10 hit points. Okay, so this is how you use the factory method to concentrate the place where you create your instances in one place. You create your instances only through the create game artifact method. That's the first thing. The other thing, you decide at runtime what type of artifact you are going to create. For example, you have 10 enemies, but only one NPC and no bombs. So you decide that at that moment you don't need to create more enemies. You create a couple of NPCs and a couple of bombs. Okay, this is an example for that. Now we are going to implement the part where you start to abstract the factory a bit. Okay, so I'm going to implement this. I'm going to comment this code, and I'm going to actually add certain types of enemies. I'm going to do the following. I'm going to extend this architecture to include these 3 types of enemies, and I'm going to start implementing this. I'm going to implement an abstract factory, and I'm going to implement a enemy factory that extends the abstract factory, and then I'm going to show you that we can combine the abstract factory and the factory method. Inside the enemy factory, we can use the same code that we have implemented here. And after that, I'm going to create different types of factories to create different types of elements. So let's see this. So I'm going to export an enumeration which is called enemy type, and that will be, for example, knight, taking the constant of 1, a mage, and undead, for example. Okay, and we are going to the game element, and I'm going to import the enemy type here, and I'm going to create, for example, export class. The knight class will be actually the same, so I'm not going to type that all along. I'm just going to copy that, and I'm going to explain. So the knight class will be extending the enemy class. It will be receiving the name property as before. It will be saying something like knight created, I'm evil but glorious. It will be moving in a different way, which means to represent that fact we will be outputting a different string. So for example, the knight is riding his horse. It will be acting differently. He has attacked you, for example, and you lost only 5 hit points instead of 50 points when Diablo himself attacked you. So we will do the same for implementing the mage. So the mage will be extending the enemy as before. Mage will be saying something. Instead of moving, the mage will be teleporting, and the mage will be turning his enemy, the player, into a sheep, for example. Okay, and the undead. Okay, so for implementing the undead, as before, the undead will be saying something, my farts will kill you, ha ha ha. And he will be walking towards you, and he will be attacking you with cyanide farts. Okay, and that might actually kill you. Okay, now what are we going to do is comment this, and we are going to create an abstract class, abstract class factory, and we are not going to instantiate this abstract class. We will be just using it in our further factories that we are going to implement based on this. And we will be having a create game element as before, and that will be receiving a parameter of the name parameter and the element type parameter, which is either artifact type or it will be a enemy type. And I think we don't have that imported, so enemy type. Okay, and yeah, that's it for the abstract base factory. We are going to extend that, so export class enemy factory extends, if I can spell it right, so constructor and a call to super, because this is a subclass. And here is the create game element and name string and element type is going to be of type enemy type. And here we are going, as we said, This is a combination between the abstract factory and the factory method. We declare a abstract class factory, we extend that, but we can also use the factory method inside this extended factory. So we can do something like this here, okay? But in our case, we are going to implement an enemy factor instead. So we are going to say switch element type, and in our case we have enemy type night, return new night name. Okay, case 2, enemy type, we have what? We have a mage, and in that case return new mage name, and case 3, enemy type undead, return new undead name. Okay, and of course a default case, throw unsupported enemy type. Okay, so this is one way to do this, or we can check, we can try that. So for example, artifact type, let me implement and let me import enemy type, and the factory is called enemy factory. So enemy factory, so let's say const factory or enemy factory. Enemy factory is new enemy factory. Okay, and let's create a night equals enemy factory, create game element, and I don't know, night of knee, and enemy type will be night. Okay, const, let's say Merlin enemy factory, create game element, Merlin enemy type will be mage. Const, do you know any famous undead? Let's say, oh, Arthas, for example. Arthas. Okay, enemy factory, create game element, Arthas, and enemy type will be undead. Okay, so now let's check the enemy moves, the night moves, night acts, Merlin moves, for example, Merlin, oops, acts, and of course Arthas moves and Arthas acts. So let's check this and see what's going to happen. So clear, here you can see So Merlin created, who disturbed me, Merlin created, I conjure and cast spells, Arthas created. Again, the base class, Arthas created, my farce will kill you. Knights of Ni is riding his horse. Knight of Ni has attacked you, you lost 5 hit points. Merlin is teleporting, Merlin has turned you into a sheep. Arthas is walking towards you. Arthas has attacked you with cyanide farts, you've lost 50 hit points. Okay. So you see this also works. Now we are going to do the last thing, which is abstracting the factory itself completely, which means we are going to implement these factories, and we are not going to use a switch statement inside the factory. We are going to directly, because we know already that we are producing certain type of elements, we are going to produce either directly knights or either directly mages or either directly undeads. So let's go and do that. So the factory here is going to be extended, and that's going to be for example a knights factory. So I'm going to copy this. So knights factory extends enemy factory. It has a constructor and it has the create game element, which receives only the name parameter, and it returns a new instance of knight. And we can do the same for a mage. So for a mage, and okay, for a mage factory, undead factory, etc. All the same. The point of this is that you can have one abstract factory which you can specialize more and more and more, and each subclass, each subfactory will be specialized in creating a certain type of elements, and that will allow you to be free to extend your gaming architecture the way you like. For example, we discussed only extending the enemy architecture, but you can also extend the NPC, for example, tree. You can create a complete different tree for NPCs here, and that means you can extend both trees independently. This will gives you an incredible freedom of versatility and creating a robust software. So in this case, I think we are done here. Just going to change this. So we are not going to, okay, I'm going to comment this here. So, and I'm going to create 3 factories. Knights factory, which will be a new oops, I need to import that. So enemy factory, I need to import knight factory, or yeah, mage factory. So mage factory and undead factory. Okay, so the knight factory will be knight factory, and we are going to also create a mages factory, which is a new mage factory, and of course undead factory, be new undead factory. And here we are going to create the knight based on each different factory that we have created. So we have create game element, and that will be what? Knight of Ni. So that will be it. Const Merlin will be a use factory create game elements, and his name is Merlin, and the last one will be Arthas, and for example undead factory create game element, and the name will be Arthas. So I think that's it. So let's try this again. Clear and see how it works. Yep, it works. So here you can see the specialization of factories and making each factory responsible for creating only one type of artifact or game element. For example, the knights factory produces only knights, the mages factory produces only mages, the undead factory produces only undead. Okay, and that actually is it. That's all you need to know about the factory design pattern and the abstract factory. I also have a video on creating the factory methods and the abstract factory design pattern using C++. It's an older video, but it's still actual. If you are interested in that, you can check that. I will leave the link in the description. Also, I'm going to leave the code in my GitHub account, so you can grab that from my repository. And what else? Please share, like, and subscribe, and leave any comments below. I'll try to get back to you as soon as I can. So see you in the next one.